For nearly a century, our universe's story has started with a single, explosive event, a singular moment where all space, time, and matter erupted outward from an unimaginably hot, dense point. This idea of a finite origin was first mathematically formalized by physicist Georges Lemaire in the 1920s to explain why galaxies are actively flying apart from one another. But there is a major problem hidden inside that origin story. When cosmologists run the expansion of the universe in reverse, winding the clock all the way back to the absolute 0-second mark, the mathematics completely break down. That initial starting point is not a proven physical reality. It is a mathematical glitch, a hard error where our current understanding of physics simply fails. To understand why the math breaks, we have to look at Albert Einstein's theory of general relativity. This framework perfectly describes gravity on a large scale, treating space as a smooth, curving fabric that bends around massive objects like planets and stars. But tracing the universe back to a single point requires a parameter called a singularity. This state demands that the entire mass of the universe be packed into exactly zero volume, resulting in infinite density. Einstein's equations cannot divide by zero, and they cannot compute infinity. When gravity becomes that intense, the calculations produce nonsensical results, rendering relativity completely blind to the actual birth of the cosmos. To see past this glitch, physicists realized they needed to bridge a gap. They needed a single theory that could account for both the massive curvature of gravity and the granular, microscopic rules of quantum mechanics. Enter loop quantum cosmology. This is a specialized branch of physics designed specifically to resolve Einstein's blind spot by examining the microscopic architecture of space-time itself. The core premise here is that space is not a smooth, continuous fabric. Zoom in far enough and space is pixelated, constructed from finite, interlocking quantum chunks. These loops act as a physical barrier. As matter compresses, these structures lock together, creating a hard physical limit on how small space can be squeezed. Physicists call this maximum limit the Planck density. It is roughly equivalent to compressing 1 trillion solar masses down to the size of a single proton. Because the universe has this built-in minimum pixel size, reaching a volume of exactly zero is physically impossible. The singularity glitch is mathematically erased from the system. This introduces a fascinating new question. If a contracting universe cannot crush itself into a singularity, what happens to all that momentum when it hits the uncompressible wall of the Planck density? At this extreme limit, the rules of gravity flip. Instead of pulling matter inward, the quantum geometry of space reacts to the immense pressure by exerting an extraordinarily powerful repulsive force. The momentum violently reverses. The quantum loops push back against the crushing weight of all existence, blasting matter and energy outward. Physicists call this explosive rebound the Big Bounce. In this model, the death and collapse of a prior universe acts as the direct spark that ignites our own. Most models have to add a separate, mysterious ingredient called inflation to explain why our universe grew so fast and evenly. But as this research shows, that rapid expansion happens as a natural result of the bounce itself, without needing any added assumptions to make the math work. If loop quantum cosmology is correct, our universe did not emerge from nothingness. It is a recycled iteration of a cosmos that existed before. And if a bounce created our current reality, there is every mathematical reason to expect the process will repeat. Physicist Roger Penrose developed a framework to map this eternal chain, calling it conformal cyclical cosmology. Penrose calculated that our universe will continue expanding until all matter eventually decays into pure light. At that stage, the universe loses all sense of time and physical scale, creating a state that mathematically mimics the exact conditions of a new Big Bang. In this theory, our entire universe is just a single eon. It is one temporary lifespan serving as a single link in an infinite chain of cosmic reboots. This is entirely different from older, disproven ideas like the steady-state model, which assumed the universe was eternal but remained static and unchanging over time. The Big Bounce is highly dynamic, and scientists are actively searching for its physical evidence. By scanning the cosmic microwave background, they are looking for specific ripples in spacetime, fossilized gravitational waves left over from the collapse of the previous universe. This symbol represents a shift in our perspective. It suggests a universe that doesn't just happen once, but functions as a continuous, large-scale cycle. The universe has no true beginning, and it faces no ultimate end. The death of one reality is the exact mathematical requirement for the birth of the next.